Welcome to myprojectbazaar.com. Our product title is a compact area low VDD minimum 60 SRAM with improvement in cell stability, read speed and write margin using a dual split control assist scheme. Now we are going to discuss about our product abstract. Our main process for using novel 60 SRAM memory location process. So the main concept for the read and write operation using the dual split control scheme. So this is the main objective for improve the cell stability and read and write operations without the degrading of some cells process. So the development of the voltage and the 60 SRAM process generated by the constant voltage source. So particularly we required for the some large number of voltage should be the small and possible to avoid the degrading the stability and inactivations for cell on column. So we are using the transistors, two additional transistors separate the read port and decouple of the read path. So in the storage functions, so and the read and write operations to increase the margin on noise level to distribute for the additional layout of the functions. So in the main 60 SRAM process we can connect it to the either input and input means the write operations in the input of each cells. So we give the some pulses or voltage source we can generate from the some cycle read and write cycles from the voltage operations. These write operations we can getting from the some voltage sources. We connecting the maximum of voltage drain voltage in the selected columns. The large number of area and power in the small amount of the column. So multiplexing the each and every cells in the control scheme. And then main inverting process, the CMOS technologies, we can utilize the write and read operations in the concept of the inverter process. The inverter the combination of the NMOS and PMOS both connectivity we get the some Q and Q bar process in the using the process in the feedback line. So the dynamic we can connect the control system. The same method after we get the dynamic feedback from the each and every and Q bar equalization and then the line voltage for the some read and leakage sections. So main object of we control and leakage voltage and current and improve the RBL sensing process. Now we are going to discuss about our product flow diagram. So in this process initially we give the some input bit. So it means like a pulse or some voltage we give the some source of the input. After with the SRAM bit cell group, so group of architecture for SRAM. So mainly use the single cell storage process in any type of memory architectures, and the architecture requires less power consumption and storage for the one bit. The SRAM architecture we can consume the less energy due to the internal memory placements. After to design the SRAM cache architecture also, the data first write and memory with the help of NMOS. So we using the read path function in first condition of the write getting the some written data in stored to the memory. The data stored in the memory with the help of the cross inversion circuit. Then the data is stored to the two node of left node and right nodes. So after we go into the read bit line sensing process. In this read bit sensing process we get the 60 SRAM cells. The data will be first write and then the data will be stored in this SRAM memory location. The stored data will be reading depending on the read write RWL read word line process. The read word line will be the one then store the data will be read the read bit is the RBL. So this is the read bit sensing process. After the side we give the some selection bit. So we can give the some selection bit oriented with the set the selection bit for the process. This selection process, the address selection process is to be identify the correct data in overall memory array cell functions. Then to select the read data process using the some decoding architecture, and we design the implementation for the SRAM memory array architectures. And then to enhance read performance level to overall SRAM memory designs, the decode architecture in to consist a basic of logical gate array and the structure of the input decoding process. So after we the selection process for the addresses. So in the address process we give the some first writing process to do the SRAM memory process. After finally the read bit function for like the type of address decoding sensing scheme read the stored data very fast, and the consist of the combination of RBL cells. These functions is to improve the read performance level to reduce the overall leakage power consumption, and store the data must be read the read bit line. So in the SRAM we can correct write data in the memory location and the read the data. Now we are going to discuss about the product running procedure. In our process, the novel 60 SRAM process designing in the standard tool EDA 13 versions. So this process very important for the setting the library for the directions. So the simulation setup for here. So this is the transient Fourier analysis timing for the step on the clock pulse is the stop and rising time, the initialization the analysis depot for here. So this is for the mandatory for the each and every process we give the some rising for stop and starting time. So okay, this process after we give the same location for the, so this is the location for that the general setup the simulation space simulation for here. This is a library files which we have using the some nm nanosecond, we have using the 28 nm. So we have generate from the library from here we using the some library functions. So this is setups very important. So this is a setup here we getting the where we have using the library which we want our libraries we have using the this location from here. So this process completely we can designing process. So after designing completed we are going to the running the simulation for the tanner process. We getting the two type of tools is give the output tool we generate for the spice and W-edit waveform process. So W-edit waveform give the some the math graphically we give the some input and output process, the graphically we give the, so this is the output process for the so W-edit waveform. So input read and write operation here. This is the write bit line and read bit line. So we have using the some full 0 to 200 nanoseconds we give the some data bit write at the same time. This is the control process read which we want this system we want connect out the read and write the process. This is the read process. So this is a control system for process. So this is the read write enable line voltage process. So after completing this process we give the some simulation status. So this is a timing process. So total timing, so 1.3 seconds we have using the nanoseconds process. So after complete this process very important for the power calculations. So power calculation we have using that from here. So file export space process. So we give the same process export. After we give go into the setup for the simulation getup the location of the generate the 0 edit files. So this is T space documentation of the file. So this process we give the some power calculation of the process. So finally we received the some calculation for the output file for the cell 0. So we have having that power how many power we have generated using this process 60 SRAM process. So this is very important how many power consumption we reduced and leakage process, that kind of we have using this process. So finally the delay and power process. So this is the power result for the voltage source 2. So maximum power and minimum power, this is average power. So at the same time for the timing for the delay timing process. So this is the main output for the this 60 SRAM process. objective of how to we reduce the power and how to we utilize this timing, the minimize the each and every delay timing process. Thank you watching our video.